Fields. They run through the entire universe, and particles are excitations of their quantum fields. We feel their effects, but what are they? Imagine a group of springs, each with a ball on top, all joined by rubber bands. If you tap one of them, all of them move. They create waves throughout the springs, which are comparable to excitations in the field that are fundamental particles. One fundamental particle is the Higgs boson. This particle's field gives mass to all other fundamental particles. There's a reason we all have mass. We don't get our mass directly from the Higgs, but since we're all made up of fundamental particles, they add up to create our mass. To show this better, imagine Barack Obama having a party. There's tons of people in a giant room, and when he walks from one end to the other, many people interact with him and stop to talk to him. If me or you were to walk through that same party, we could most likely walk from one end to the other without stopping. The people at the party interact more with Barack Obama than with me or you. This equates to how much the Higgs field interacts with each fundamental particle. The more interactions a particle has with the Higgs field, the heavier it is and the slower its velocity is. Since the Higgs boson is a particle, it has a corresponding field. Most fields have a resting value of 0, but the Higgs field is weird and rests at 246 gigaelectronvolts. If the field were at any other value, bigger or smaller, atoms would change size and things would cease to exist. At one point, the Big Bang, the Higgs field did have a value of 0. It was extremely unstable at this point, like an upside-down pendulum trying to stay balanced at the center. When it's at 246 GeV, it's resting on either the right or left side. During the Big Bang, the universe was super dense and temperatures were ridiculously high. That pendulum wouldn't be resting or balancing at the 0 mark. It'd be bouncing around, back and forth from left to right, and averaging out at that 0 mark. At this point, every particle and boson are massless and travel at the speed of light. The strength of the Higgs field determines the mass of particles, and the mass of the electron then determines the size of atoms. The lighter the electron, the larger the atom. Atoms the size of the universe are useless, and life wouldn't be able to be formed. If the Higgs field is at 0 GeV, the electron is massless and atoms would cease to exist. Every particle would be the same. We need the Higgs field at this very specific value of 246 GeV, or else the universe wouldn't be the same. Special thanks to Vi Hart for the inspiration.